things that are important when it comes to circle analytical geometry. So the first thing that's important to note is that when a circle is not centered at the origin, it takes the form x minus a squared plus y minus b squared equals r squared. That's on your formula sheet, okay? How in this form, this is called center radius form. In this form, how do I know? Oh, yes, 5.7. Oh, yes. Okay. Where was it? It was over here, wasn't it? Okay, let me just get my head back into the game here, Tisha. So we worked out that it would have to be between 0 and 2 because that's where it was a tangent. Determine the maximum value of, all right, so here of h of x. So h of x is 3, f of x minus 6. Okay, so what was f of x equal to? F of x was minus x squared plus 2x. So this is 3 minus x squared plus 2x plus, what was it? Plus 8, which is what f of x was, minus 6. So let me just clear some space here, Tisha. All right, so now when we come down here, we've got this is equal to minus x squared plus 2x, and then here that would be plus 2, like so. Okay, so I'm going to go back and see. Okay, so this was out of 3 marks. Sorry, I just want an indication of how many marks it was going to be out of. Now that we have done that, they want the maximum value of the expression. I think what I would do here is I would use x equals negative b over 2a, all right, to work out what the x coordinate is at your maximum. Okay, so here I would say negative b, so that would be negative 2 over 2 times a is equal to negative 1. So this means that it's going to have a maximum at 1. So x would be equal to 1 at the maximum. And then what I would do is I would go back here, Tisha, and I would sub in the 1. Okay, so in other words, negative 1 squared plus 2 times 1 plus 2, and then that gives us 3. Oh gosh, sorry, I'm kind of squashing all of this in here. So that would give us 3 to the power of what? 2 plus 2 minus 1. So that would be 4, take away 1. 4 minus 1 is 3, isn't it? So 3 to the power of 3 would be 27. Okay, so that would be your maximum. Okay, Tisha? And everybody else? Are we all good with that? Matrix, is that okay? Yes, Kulani, all right, cool beans. Okay, so what I'm going to do is I'm going to fly back to circles and we can continue talking about this. Okay, so circles not centered at the origin. If we change the coordinates of A and B, that gives us the coordinates at the center. Okay, over here, what does the letter R represent? R stands for? For the radius, quite right. Okay, so it stands for radius. So therefore, r squared means it is the length of the radius multiplied by itself. Okay, the other thing that is important to us when we do circle analytical geometry, right, is the gradient of a tangent times the gradient of a radius always gives us -1, because a tangent is always perpendicular to a radius. So in other words, if we just draw ourselves a quick circle over here, there's our circle. Let's just draw a radius. So from the center over here, let's draw a tangent to the circle. Okay, there we go. We've got that. So over here, there is always going to be a 90-degree corner. Okay, so there's your radius. Here's your tangent. When we multiply the gradient of these two, we're always going to end up with -1. Okay, so this is important to help us find a gradient of either a radius or a tangent if we know the gradient of the other. So in other words, if I know the gradient of the tangent, I can use this to work out the gradient of the radius. And if I know the gradient of the radius, I can use it to work out the gradient of the tangent. Okay, so you must never ever forget about this. Very, very important. Okay, because these two make a 90-degree corner, the other thing that we must not forget about is the fact that we can connect those two. Sorry, I wanted it to be a different line. Let me just rub that out. We can connect these 2 points together. It's going to give us a right-angled triangle. And if we've got a right-angled triangle, it means we can always use the theorem of Pythagoras. Okay, so to work out the length of a line. So you are allowed to connect a point to another point to make a right-angled triangle. We're not supposed to be doing constructions, but that is allowed. And then we can use Pythagoras to help us in this regard. The other thing that we need to bear in mind, and I don't think we're going to see that today, is that the equation of a circle that is not centered at the origin. Okay, so this is not centered at the origin, has got the x minus a squared plus y minus b squared equals r squared. If it is centered at the origin, what is the equation of the circle? What is the equation of a circle if it is centered at the origin? Matrix. You guys are so quiet tonight. So Tabelo, that's the coordinates at the center, sure, but what's the equation of a circle that is centered at the origin? How does it differ from what we have here? Okay, so it takes the form. There we go. Thank you. Okay, so x squared plus y squared equals r squared. Okay, so that is the circle if it is centered at the origin. Okay, the focus of our study in metric is this, but every now and again, we sometimes have to work with these as well. So that's really important. The other thing that you can have is tangents from the same point are equal, which we get from Euclidean geometry. So tangents from same point are equal. And the last thing that I want to point out to you before we move on and start answering these questions is something that you're going to probably say to me, well, that's really obvious. Why are you saying it? But when we're doing these questions, it's not so obvious. So radii of the same circle are all equal in length. Okay, so I'm dropping some major hints here. Okay, so radii of the same circle are all equal in length. Okay, so that's basically the circle in a nutshell, the things that we need to know. Let's go and have a look at the first question. All right, so here they tell us in the diagram below, M with coordinates P and minus Q is the center of the circle. C and D are its x-intercepts. Two tangents drawn to the circle at C and D respectively meet at E. Line EM intersects the circle at 2 and 2. And line BC is x plus 1 units. So if E and A and B and M are all in the same vertical line, which they have to be because that line is parallel to the y-axis, what does it mean about the coordinates, or at least the x-coordinate at E and A and B and M? What does it have to be? Has to be the same, isn't it, Tisha? It does. Okay, if they're all in the same vertical line. So what would it be in this case? There's a specific value that it would have in this case. What would that value be? It would be 2, absolutely. Okay, so they would all share the same x because they're in the same vertical line. They would have different y's, but they would share the same x. So question 4.1.1 asks us to write down the value of p. So what's p equal to? P is equal to 2, precisely. Okay, so that was easy enough. We'd get 1 mark for that. Okay, now the next question is not so straightforward. They want us to prove that Q is equal to 3. Okay, it's out of 5 marks. Okay, so I want you guys to look at the diagram. Okay, I'm not going to tell you what the answer is. You guys are going to have to come forward with suggestions. And I want you to look at the picture. I want you to find Q. And I want you to tell me how you think we would prove that Q is equal to 3. What can you see in the diagram that you could potentially use? What are you drawn to straight away? What do you notice? Do you see a Q anywhere? I mean, if they want us to prove that Q is equal to 3, where do you see Q or Qs? Okay, so what is the distance? Okay, so AM is a what, Tyler? I like what you're saying here. So what is AM? AM is a? So no, AM is not 2 plus 2 necessarily, no. AM is a radius. Okay, and you're right, because of that 2 over there, what is this? That means that from here, from A to B, this bit is 2. Because remember, a y coordinate tells us how far a line is from the x-axis. An x coordinate tells us how far a point is from the y-axis, right? That's what it means. All right, so in other words, A is 2 units from the y-axis and 2 units from the x-axis. So quite right, that means that AB is equal to 2. What is BM equal to? Capano, do you know? What is BM equal to? Anybody got an idea? What would BM be equal to? You've got the coordinates at M. Why do you think it should be 1, Capano? Tisha reckons 2. Remember, coordinates tell you how far a point is. Blankenberg says 4. Okay. What does this P tell us over here about M, point M? All right. So B and M have the same X value. They certainly do. All right. So at M, the value of P tells us how far M is from the y-axis. Okay. So this little P over here, all right, tells us, so P tells us how far M is from the y-axis. That's what an x-coordinate does. This minus q over here, minus q, tells us how far M is from the x-axis. So in other words, if we're standing at M and we want to get to B, we've got to go Q units up. So the length of BM is Q from here. So that means that AM is 2 plus Q. Okay, so the 2 from here and the Q from there. Okay, it tells us that B is Q units from M and A is 2 units from B. Okay, so the length of AM is Q plus 2. Now that's important to us because AM equals what other line in the circle? Is there another radius in the circle? AM is a radius. Is there another radius? Okay, so MC or CM is also a radius, quite right. So from M to C, that's also a radius. So that we can say that AM and CM are equal to one another because all radii are equal. So that means that CM is also 2 plus Q units in length. Triangle BMC is a right-angled triangle. If this line over here is parallel to the y-axis, then it means that this has to be a right angle. So here we have a right-angled triangle. If we have right-angled triangles, we can use the theorem of Pythagoras. Okay, so in question 4.1.2, this is what they want from us, to show that Q is equal to 3. So 4.1.2, this side over here, BM, so BM squared, plus this side over here, BC squared, is equal to the hypotenuse, which is MC squared. Now we're going to sub in BM is Q squared, BC is Q plus 1 squared, and MC is 2 plus Q squared. So in other words, if they want us to prove that Q equals 3, we cannot verify by substitution. We have to make an equation and we have to solve for Q. Okay, so this was a very, very difficult thinking question, which I'm sure would have put a lot of people off the rest of the questions. Okay, but because they told us that Q was equal to 3, it means they gave us the answer. So at least we would be able to continue with the rest of the questions, even if we were not able to do question 4.1.2. So now solving for Q, we would end up with Q squared plus squaring our binomial. Remember, it has to have a middle term, plus 2Q plus 1 is equal to 4 plus 4Q plus Q squared, like so. All right, so remember when you square a binomial that you have to get a trinomial. Okay, it has to have a middle term. So if we collect our Q squareds all on one side, we would end up with 1Q squared. I'm going to bring this 4Q over to the other side, so that would be minus 2Q, and I'm going to bring the 4 over to the other side, so that would end up being 1 minus 4, which would leave us with negative 3. Don't forget, we've got to make it equal to 0. So 2 possible solutions for Q in this case. One's got to be positive, the other one has got to be negative. All right, so we're going to have to make a decision about our answer. And here we would use 3 and 1. So it would be negative 3 plus 1. So 2 solutions for Q. Either Q is equal to 3 or Q is equal to negative 1. Is it possible for Q to be equal to negative 1? Remember, Q is the y coordinate. We are working in quadrant 4. Okay, so absolutely. All right, so this cannot be, because then we would have a positive y coordinate over there. So we've got to remember to put a line through the equal sign. So we're going to accept where Q is equal to 3 only. Okay, and of course they told us there that Q was 3, so we've got the right answer. Okay, so yeah, not an easy question. Here I imagine that there would have to be a mark for knowing that BM was Q and a mark for knowing that MC was 2 plus Q squared. Standard form answer, maybe a mark for using the theorem of Pythagoras. Okay, so that's how we would have answered question 4.1.2. So in 4.1.3, they want us to determine the equation of the circle in the form x minus a squared plus y minus b squared is equal to r squared. Okay, so we need to remember this is center radius form. A and B are the coordinates at the center. and r squared is the radius squared. So we have to fill in A, we have to fill in B, and we have to work out what r squared is equal to. So can anybody tell me what they think now that we know what P and Q are equal to? How would I start off question 4.1.3? What do you think I should write? That's it, can you see there? So we would sub in A and B. Lovely. Okay, so here this would end up being x minus 2 squared plus y plus 3 squared equals r squared. Does that make sense to everybody? Okay, so I've got to sub in my A and my B first, just like Kanisile said. Then we're going to sub in the coordinates of A, you said, to solve for R. Well done, Kanisile, that's perfect. Okay, so now here we know that this is 2, we know that that's 2. So this is going to give us 2 minus 2 plus 2 plus 3 squared is equal to R squared. And therefore R squared would be equal to 25 in this case. All right, so the equation of the circle, it is x minus 2 squared plus y plus 3 squared is equal to 25. Okay, how are we all feeling so far? Can we have some emojis? Is this making sense? Are you okay? Cool, Kanisile. Cool, Kulani. Cool, Tisha. Nice, Chiamo. Okay, let's continue. So in question 4.1.4, they've now asked us to write down. Okay, so we don't have to calculate or determine, right? We just have to write down the coordinates of C and D. How are we going to work out what those are? How are we going to work out what the coordinates at C and D are? Quite right. Can you see there? Y does represent 0. Lovely. Okay, so it's the x-intercept. So y is equal to 0. Also remember what we've already got. We know the length from B to C, don't we? Because we know what Q is equal to. You could do that. You could sub 0 into the equation. You don't need to do that, but you could. So what I'm trying to suggest here, Kanisile, is this. Use what you've got here. Okay, Q is equal to 3, remember? So what's the length of BC? BC has to be 4 units. Okay, remember when we are over here, X is equal to 2. So if we're sitting at 2 and we move 4 units to the right, that means that C has to be at 6. Does that make sense to everybody? Yes, good. All right. What would the coordinates at D be then? Tisha, what do you think? What are the coordinates at D? Yes, yes. Good, Mr. Bavuma. What do you reckon, Tisha? What are the coordinates at D? Remember, you're sitting here at 2. At B, X is equal to 2. And the distance from B to C has to be the same as the distance from B to D, right? So 2 minus, that's okay. Can you see it? 2 minus, not 5. That's it. Good. Good, 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 good. All right. So the coordinates here have to be -2 and 0. Okay. Good job, guys. Well done. Yes, Kulani, 100%. Okay. So you can do what Kanisile had suggested. right? You would get the same answer. Here, they didn't want us to actually do that. They just wanted us to write it down. But I'm just showing you what Kanyisile was saying. Maybe let me just move this question out of the way. Back down a little bit. Whoopsie. Okay. So coming back here. All right, so Kanyisile said, if we use the equation of our circle, which is this one over here, we can make y equal to 0. So we would end up with x minus 2 squared plus 0 plus 3 squared equals 25. This is going to be a lot longer. We'd end up with x squared minus 4x plus 4. Sorry, not equals, should be plus. And then here we would have 9, and then we would say minus 25 equals 0. So we'd end up with x squared minus 4x, and then that would be what, 13 minus 25, which would leave us with negative 12. And then we would have to factorize. And we would end up with those answers. Okay, so either x would be equal to 6 or x would be equal to negative 2. Okay, but we were able to do that without having to use this method because they told us the distance from B to C, and the distance from B to C is the same as the distance from B to D. Okay, but you would have got the same answers anyway. All right, question 4.1.5 now. Calculate the gradient of MC. So that's easy enough. Okay, so what they did here is they pulled a little bit of a dirty in this question where they made question 4.1.2 really difficult, but then the rest of the questions that come after that are actually a little bit easier. Okay. It was smart, wasn't it? Hey, there's good thinking on Kanyisile's part as well. All right, so the gradient of MC, well, we know at M the coordinates are, at M we know the coordinates are 2 and negative 3. At C we know the coordinates are 6 and 0. So calculating the gradient of MC is super easy for us. We're just going to use gradient formula. Okay, so the gradient of MC, sorry, which question is this? 4.1.5, I think. Yes, so we would have 0 plus 3 over 6 minus 2. Okay, which would give us 3 over 3. No, sorry, 3 over 4. Okay, so the gradient of MC is 3 over 4. The line slopes up to the right, so we are expecting a positive answer. Cool. So 1 mark for subbing in, 1 mark for the answer. Determine the equation of EC. Okay, so EC is this line over here, matrix. I'll put it in pink. Oopsie, not very straight, but anyway, there we go. All right, so there is EC. They want the equation of EC. So now what are we going to do? No, you never get a mark for writing a formula that's given to you. Okay, you get marks for subbing into a formula. Blankenberg, I don't know whether it's Miss or Mr. Are you a boy or a girl? Because I suspect Blankenberg is your surname. Okay, Miss. What's your name? Kaylin. Hello, Kaylin. Cool. It's nicer to call you Kaylin than it is to call you Blankenberg. All right. So Kaylin, no. In maths, you don't get marks for writing down formulae. You get marks for subbing into the correct formula. Okay, and they're quite sticky about that. So, you know, if you did use an incorrect formula in a particular place to calculate something, you wouldn't get method marks for subbing into an incorrect formula. So yeah, we've got to make sure that when we do use our formulae, we are selecting the right ones. Okay, so the equation of EC. Remember, MC is a radius, EC is a tangent. Hint, hint, hint. MC is a radius, EC is a tangent. Exactly, can you see that EC is perpendicular to MC. EC is perpendicular to MC. So what should we do here as far as calculating gradient is concerned? Can anybody tell me? Okay, so we're going to find the gradient of MC. All right, so the gradient of MC, okay, which we've got. So in 416, what we can say here is that the gradient of MC multiplied by the gradient of EC, the tangent, gives us -1. So that means, oopsie, sorry, pressed something weird here. Sorry. So that means that 3/4 times the gradient of EC is equal to -1. So the grade, sorry, this is because the radius is perpendicular to the tangent. I should have put my reason in. So that means that the gradient of EC is going to be equal to -4/3. Now that I've got the gradient, I can take the gradient and I can go and sub it into y equals mx plus c. So y equals m being -4/3, x plus c. It's our job to work out what c is, the y-intercept. So now we need a point. Okay, we don't know what the coordinates at E are, but we do know the coordinates at C. They are 6 and 0. So that means that we can go and sub in C. Okay, so point C. Okay, which has the coordinates 6 and 0. So 0 equals -4/3 times 6 plus C. So C has to be equal to what matrix? Just move these down again. Okay, so Kanyisile says 8. I agree, Kanyisile, I also get 8 as an answer. Okay, so the equation of EC is -4/3. Don't forget about the x, plus 8. Okay, good. Well done, Kanyisile. Well done, Kulani. All right, quite right. So there we go. We've done 4.1.6, the equation of EC in the form y equals mx plus c. Okay, the last question here that they want us to do is the coordinates at E. Okay, so remember, E represents a point of intersection. E is a point of intersection. Actually, yeah, E shares an x coordinate with A, 100%. So already at E, we know that x is equal to 2, don't we? Which just means that it's our y coordinate that's missing. So what can we use to help us? We know the equation of EC. So that means that we can calculate what y is if we know what x is, exactly the equation from before. All right, so in 4.1.7, we're using y equals -4/3 when x was equal to 2 plus 8. Okay, so that gives us do you get 16/3? Yeah, me too. Okay, so the coordinates at E, oh, what sort of E is that? Goodness me. So the coordinates at E are 2 and 16/3. If we go back and we go and have a look at the diagram, we can see E is a point in the first quadrant, so that makes sense to us that those would be the coordinates. Okay, how's everybody feeling? Do you want to send us an emoji? Is this making sense? Oh, cool. Oh, good. I'm glad, Shyamo. I'm glad, Kanesile. Kalani, nice. Cool, Tisha. All right. So if everything is okay with that first question, we can go on and have a look at the second question that I wanted to do with you this evening. Okay, so the second question that I wanted to do with you was this one. It's quite similar to the one before, actually, but it's similar, but it's not exactly the same. All right, so here they have given us the equation of the circle. They've told us the equation of the circle, x minus 2 squared plus y plus 2 squared equals 17. So we can see here this has been given to us in the form x minus a squared plus y minus b squared equals r squared. So if we just look at the equation, can we work out what the coordinates at M are? So from looking at this that I've highlighted in yellow, what are the coordinates at M? There we go. Okay, so the coordinates at M have to be positive 2 for x and negative 2 for the y coordinate. Okay, and of course, M is a point in the fourth quadrant, so that makes sense to us that it would have the coordinates 2 and negative 2. What does the 17 over here represent? What does that mean? What are they telling us? Yeah, r squared. Okay, so just be careful. On the right-hand side, this is r squared. So r squared is equal to 17. Okay, so if they did ask you for the length of the radius, you would have said root 17. I don't think it's one of the things they're going to ask us, but there we go. Yeah, 100%. So the other thing that they tell us is that A and B are points on the circumference and the line AB, which has an equation y equals -1. So we know that both A and B have a y coordinate of -1. Y equals -1 is the equation of a horizontal line. Okay, so all lines that start with y equals and it's just a constant are going to be horizontal. Okay, the next thing they want, okay, so over here, so we've already done this. So in M, we've calculated that the coordinates were 2 and -2 at the center. Now they want us to calculate the coordinates of A and B. So what should we do here with the information we've been given? What do you guys think? How would we work out the coordinates at A and B? Remember, we already know what the y coordinate is. A and B are points that lie on the circle. So what do they want us to do? Exactly, they want us to sub the -1 into the equation. All right, 100%. So in question 4.1.2, we are going to write that x minus 2 squared plus, and then in this case, y has got to be -1 plus 2 squared has got to be equal to 17. Okay, so it's quadratic. We're going to end up with 2 solutions for x. Remember, matrix, when you square your binomial, okay, you have to have 3 terms. Okay, an x squared term, an x term, and a constant term. So this gives us x squared minus 4x plus 4 plus, that would be 1 squared, which would be 1 minus 17 is equal to 0. So this would give us x squared minus 4x, and 4 plus 1 minus 17 is going to leave us with negative 12. Okay, and now we need to factorize. Sorry, I'm being attacked by, well, not attacked, but Christmas beetles flying around. Okay, so factorizing. So one bracket will have x minus 6, the other bracket x plus 2 equals 0. So therefore, x is equal to 6 or x is equal to negative 2. All right, so therefore the coordinates at A have to be negative 2 and 0. The coordinates at B have to be 6 and 0. Oh, sorry. I'm being stupid here. Sorry, not 0. They're not x-intercepts, are they? Duh. We know that y was equal to negative 1. Sorry, let me just fix that. Okay, that's it. Okay, so at A, negative 2, negative 1, it's a point in the third quadrant, so that makes sense. B being a point in the fourth quadrant makes sense that its coordinates would be 6 and minus 1. Okay, lovely, guys. Well done. Okay, there we go. All right, next question. 4. Okay, so the coordinates of A and B. So that was out of 4. I just want to tell you where the marks were allocated. So here, a mark on each. There has to be a mark for subbing in the 0. There has to be a mark on those answers. How many marks was it? 4. So another mark, probably on that line. Could possibly be on that line as well. Okay. Let's continue. Question 4.1.3. I want us to determine the equation of the tangent AE to the circle at A. I want us to determine the equation of the tangent AE to the circle at A. So again, if they want us to determine the equation of the tangent, they mean in the form y equals mx plus c. So it's our job to work out the gradient and the y-intercept of the line. So how do you think we should do this, Matrix? How would we work out the equation of AE? How would we get its gradient, first of all? Gradient of AM. Okay, so teacher says find the gradient of AM, all right, and then what? Exactly. Okay, so we're going back to the same critical piece of information that we were talking about at the beginning of the lesson. So in other words, the gradient of the tangent times the gradient of the radius equals -1. Okay, so very, very important to us. So the gradient of AM, so remember the coordinates at M are 2 and -2. The coordinates at A are -2 and -1. So that means the gradient of AM is going to be -2 plus 1 over 2 plus 2. Okay, so that's going to give us -1 over 4. So that's the gradient of AM. All right, so because AM is perpendicular to AE, gradient AM times gradient AE equals -1 because the radius is perpendicular to the tangent. So if this is -1 over 4, then the gradient of AE has to be what? What are you guys getting as an answer for the gradient of AE? Four, I agree, Shamu, I agree. Can you see it? It would be 4. So now we can say y equals 4x plus c. That's fine, Tisha, no worries. Okay, so we would get 4. Now we're just going to work out the value of the y-intercept. And we're going to sub in point A, okay, because line AE goes through A. So now we're going to sub in A, which has coordinates -2, -1. So -1 equals 4 times -2 plus C. So what are you guys getting as a value for C? Seven. Good job. Okay, so in other words, the equation of AE, it is the line y equals 4x plus 7. Okay, so we've done this, we've done this, we've done this. Let's get the last one sorted out and then we can all go. All right, so calculate the coordinates of E. If BE is a tangent drawn through B and has equation y equals -4x plus 23. How do you guys think we should answer this question? What do you think we should do? All right. Simultaneous, right, Kaylin? Okay, so it would be a simultaneous solution because E represents a point of intersection. Okay, and it doesn't matter that EB is not drawn. Right, so it's a point of intersection. Equate the equations. 100% can you see there? Okay, of the tangent and the other tangent, so of both tangents. So in this case here, we would end up with, we'll just do this and then we can all go 4.1.4. So we're going to take 4x plus 7. We're going to make it equal to -4x plus 23. We're going to collect our x's one side. We're going to collect our numbers the other side. And x would be equal to 2. Okay, now that we know that, we can sub into either equation and work out what y is. So in this case, if we use that one, we would end up with 15. So therefore, the coordinates at E would be 2 and 15. Okay.